Solve 3x over x squared minus 9 plus 1 over x minus 3 equals 3 over x plus 3. So now notice that we have a term that can be factored. So here we have x squared minus 9, which is the difference of two squares. So here we have x squared minus 9, which is the square root of 9 is 3. So we have 3 squared. So we could express this as x plus 3 times x minus 3. Now to set restrictions, the denominator cannot equal 0. So we're going to set both of these equal to 0 and solve for them. So here x equals negative 3, and here x equals 3. So this means that x cannot equal negative 3, and x cannot equal 3. That's our restriction. So now our least common denominator is x plus 3 times x minus 3 here. We have x minus 3 here. Here we have x plus 3. So our least common denominator is both of them. Is x plus 3 times x minus 3. So now we're going to multiply both sides by the least common denominator to eliminate our fractions. So here we have x plus 3 times x minus 3 times 3x over x plus 3 times x minus 3 plus 1 over x minus 3 equals, we're going to multiply both sides, so x plus 3 times x minus 3 times 3 over x plus 3. So now we're going to distribute to each term. And when we do that, we get x plus 3 times x minus 3 times 3x over x plus 3 times x minus 3 plus x plus 3 times x minus 3 over x minus 3 equals x plus 3 times x minus 3 times 3 over x plus 3. So now we're going to cancel out our like terms. Here we have x plus 3, and here we have x plus 3. Here we have x minus 3, and here we have x minus 3. Here we have x minus 3. Here we have x minus 3. So what we're left with is 3x plus x plus 3. And on the other side, we have x minus 3, x plus 3 here, and x plus 3 here. So we're left with 3 times x minus 3. So now what we have is 3x plus x is 4x plus 3 equals, we're going to distribute that to each term, 3x minus 9. So now we're going to subtract 3x from both sides. So what we get is 4x minus 3x is x plus 3 equals negative 9. So now we're going to subtract 3 from both sides, and what we get is x equals negative 9 minus 3 is negative 12. So that's our answer.